although each of the steps involved in the hydrogen to helium fusion reaction have indeed been verified experimentally, the overall experiment, the overall reaction, has never been produced in a continuous laboratory experiment. Continuous hydrogen to helium fusion has not been attained in the lab. The strength, in fact, of the electric cosmology is that indeed all of the mechanisms that the electrical people talk about have indeed been verified over decades, in fact, at least a century, in the laboratory. The plasma scaling is well known, and plasma and electrical experiments have verified every step of the way. There are any number of observations that have ad hoc present explanations, but really have no explanation in the standard model, and are natural consequences of the electrical model. For example, heavy elements, the solar spectrum, the neutrino deficiency, the neutrino variability, solar atmosphere, differential rotation by latitude, differential rotation by depth, equatorial plasma torus, the sunspots, sunspot migration, the sunspot penumbra, and the sunspot cycle itself. Magnetic field strength, the even magnetic field, helioseismology, the solar density, and the changing size. All of the observations that in that list are natural consequences of the electrical sun model. Standard astronomers tend to pass them off as being inconsequential difficulties that will eventually someday be solved. I maintain, and so do our colleagues here, that these are not inconsequential, but are rather death blows to the solar fusion model, because they are important. They're not secondary. They're primary falsifying observations for that failed nuclear fusion model.
What I find so fascinating about the electric model of the sun is not just that it's a challenge to long-standing theory, but that it opens the door to the ancient world, to an electric sky. The electromagnetic phenomena that we now observe on the surface of the sun and in the vicinity of the sun are direct pointers backwards to the plasma formations that were seen above the ancient sky worshippers.
Electrical currents in space can either be invisible or they can be visible. If they're very diffuse, in other words there's very little energy per cubic meter, they will be invisible. But where that energy becomes concentrated, it will begin to glow. And we see this kind of thing in the ion tails of comets, for instance. Where the energy becomes very concentrated, we begin to see arcs and sparks, if you like. Electrical discharge phenomena. The standard theory of comets comes from the view that the solar system was formed from a rotating cloud of gas and dust, and that the planets, in some fashion as yet unexplained completely, formed from most of that gas and dust, but there were leftovers. And the leftovers are beyond sight, outside the solar system, in a hypothetical Oort cloud, as it's called. We have no observational evidence for such a cloud. The electric universe model of comets is that they are actually parts of well-differentiated planetary bodies that have in the past suffered from electrical plasma discharge machining, and that some of the surface material has been lofted into space, so it is expected to be rocky. The second thing is that because comets trace an elongated orbit, both away from the sun and towards the sun, in that trajectory its charge changes, its voltage changes. Since it spends most of its time in the outer solar system, the voltage that it has reflects the voltage in the outer solar system. But as it hurtles towards the sun, as it enters towards the Earth's orbit, the voltage is changing rapidly, and the comet has to respond to that by beginning to discharge. And that's where we see the familiar cometary phenomena of the coma and the various tails that it produces. This creates a very distinct difference between the two models, the standard model of a comet, which is supposed to be dust and ice left over from the formation of the solar system, and the electrical model, which says that a comet is an electrical body which begins to discharge as it enters the inner solar system. Ever since we've begun to look at comets in close-up, and Halley was the first one that was observed by several spacecraft close-up, it was found to astronomers' surprise that the material coming off the comet was coming in discrete jets and seemed to be coming from what looked like circular areas on the crater. But the imagery wasn't sufficiently sharp to be able to tell exactly what was going on. This required the standard model to come up with an idea that maybe the surface of the comet is coated in black tarry substance or something which was preventing the material from just evaporating from the surface and forming jets as it burst through the surface. But when later images were looked at as we passed other comets, it was found, to astronomers' amazement, that they were seeing very sharp relief. It wasn't like a melted ice cream, it was looking like a piece of heavily cratered rock. Now this fits the electric model of the electrical discharge birth of such a body. In other words, there's very little distinction between an asteroid and a comet other than its orbit. It was in this context that I looked at Comet Tempel 1, which was chosen as the target for an impact. And the idea was that the impact would create a small crater which could then be photographed by the passing spacecraft, and we could determine whether the material was ice or dust or rock based on the size of the impact crater. It seemed to me that if this comet was a charged body, there would be several other effects that were unexpected. Principally, as a metal copper object approached the comet, there should be an electric discharge to that copper projectile. In other words, there would be an initial flash, and then there would be the impact itself. And the impact, I suggested, would be far more energetic than was expected, because it would tend to concentrate the electrical discharge in the area of the impact, and also it may change the nature of the jets nearby. So it was with great interest I awaited the results of the impact and watched it on television. Before the impact, the astronomers in the assembled control room were worried that they wouldn't see anything, that the impact would result in a very small puff of dust, and that would be the end of it. So when the impact occurred, they were surprised by two things. One was that there was an initial flash, followed by the main impact, which was so energetic that some of the sensors were almost swamped, and the passing spacecraft was unable to achieve its primary aim, which was to photograph the crater. A part of the surprising brightness of the dust released from the impact with Comet Tempel 1 was due to the fact that it was so intense and so widespread. And one of the initial findings was that it seems to be very finely divided dust. Now this is the same thing that was found at Comet Halley, and it was a surprise then, so it's rather surprising that they are surprised once more. The point is that an electrical discharge on a surface will release material, dusty material, very finely divided. It's a technique that's used in sputtering of metals onto, for instance, astronomical mirrors. So this production of very fine dust is to be expected in the electrical model. But in the standard model, you are asking ices to evaporate or to sublimate, and in doing so to drive off pre-existing dust grains. So there's no way that the dust can be finely divided. It will be in its pristine state. So the production of this great cloud of very fine dust is rather inexplicable in the standard model. The electrical model of comets was driven for several people.
The strength, in fact, of the electric cosmology is that indeed all of the mechanisms that the electrical people talk about have indeed been verified over decades, in fact, at least a century, in the laboratory. The plasma scaling is well known, and plasma and electrical experiments have verified every step of the way. There are any number of observations that have ad hoc present explanations, but really have no explanation in the standard model, and are natural consequences of the electrical model. For example, heavy elements, the solar spectrum, the neutrino deficiency, the neutrino variability, solar atmosphere, differential rotation by latitude, differential rotation by depth. Although each of the steps involved in the hydrogen to helium fusion reaction have indeed been verified experimentally, the overall experiment, the overall reaction, has never been produced in a continuous laboratory experiment. Continuous hydrogen to helium fusion has not been attained in the lab. Equatorial plasma torus, the sunspots, sunspot migration, the sunspot penumbra, and the sunspot cycle itself. Magnetic field strength, the even magnetic field, helioseismology, the solar density.